Let me welcome you to the 12th lecture of surface mining technology. This is the second lecture in drilling technology for surface blasting. In last class also we have discussed the first lecture related to drilling technology for surface blasting. So, we will continue that lecture for this class also. So, as we discuss every time, this is the learning background required for surface mining technology course. This is the learning objective for surface mining technology course, and this is the expected learning outcomes from the participants of surface mining technology course. Let us retrospect our previous lecture. In previous lecture, we discussed about the current status of the surface mining. We have discussed about the phases of surface mining. We have discussed the box cut and procedure of excavation of the box cut, which is the first cut for the surface mining technology. And we have started the drilling technology for the surface blasting, and in that we have discussed about the different types of drill machines available and how those drill machines work and what are their applicability considering the rotary percussive drilling machines and rotary drilling machines. And we have seen the rotary percussive drilling machine is classified in top hammer or down the hole hammer type, and their applicability, merits and demerits are discussed in the previous class. So, objective of this is the objective of these 4 drilling lectures. So, objectives are same, but in this class we will mainly discuss about the different types of drill bits and how the drilling is carried out, what are the phases of unit operations associated with the drilling. We will discuss that in this class. So, at the very first, let us discuss about the drill bits. In last class we have discussed the rotary percussive and rotary drilling only. These drill bits what are shown in this figure are basically mostly applicable for the rotary percussive drilling system. This drilling you can see, this is called button bit. In the button bit you can see these tungsten carbide buttons. These tungsten carbide buttons are impregnated in the mouth of the drill bit. So, basically the drilling is carried out by using these bits only. So, these bits are basically hammering onto the rock surface. So, if this is the rock surface, these buttons are basically provided and this is hammered through this button. So, this as the tungsten carbide is a very hard material. So, it allow the propagation of the seismic wave which breaks the rock and make into a number of small fragments. So, this is the button bit. Button bit is in general applicable for the softer formation, where a little bit energy is required for the cracking of the material. Where a little bit hard material is there or there may be little bit abrasive material is available, in those cases cross bits are used. Cross bit you can see a bigger size tungsten carbide tip is deeply impregnated in the drill bit. So, that is why this tungsten carbide tips which are deeply impregnated in the bits gives better resistance, and in case of abrasive material it is not eroded very easily. In button bit, in abrasive material it is eroded very easily, this part is eroded very easily. So, in abrasive and hard material generally we go for opting of the cross bit. So, cross bit is very commonly used in the hard rock conditions, and these are the anchor type drag bits in different cases. These are the different types of bits where the tungsten carbide variations are provided. This is the chisel bit most commonly used for the jackhammer. Here also similar to the cross bit a number of tips are provided, but in this cases a single tip is provided and which is deeply impregnated. This is deeply impregnated with the drill rod itself. So, sometimes it is also with the bit also. So, that is this is the chisel bit, it is commonly used in the handheld drill machines or the wagon drill machines used in the jackhammer type drill machine operations. So, this is very commonly used in those cases, and these are the bits most commonly used for the rotary drilling system. This is commonly used for the rotary drilling system. You can see this is the diamond drill bits. So, these diamonds are impregnated into the mouth of the drill bit, and you know the diamond is the hardest material. So, when this is rotating, along with it is cutting the rock also or eroding the rock along with this. So, this is the different way you are placing the diamond in the mouth of the drill bit. So, this is one common rotary type of drill bit, very commonly used, but as the diamond is precious, generally these are used for the very special cases, because the price of these bits are very high. This is the second type of rotary drill bit, which is called tricone roller bit, and you can see there are 3 rollers, 1 roller, 2 roller, 3 rollers are placed at 120 degree angle to each other, and they rotate in a complementary direction as this one is rotating. So, these rollers are also self rotating type, and as it is struck with the rock, this one is rotating, this is also rotating in complementary direction, and by rotation of this, the tungsten carbide tips provided in the mouth of this tricone roller bit, that is rolling with the rock, and on rolling with the rock it is shearing the rock and failure the rock in abrasion. So, this is the way a tricone roller bit is working in a rotary drill machine. So, this is a very common drilling machine. In fact, most of the cases where the rotary machine is used, especially for the abrasive rock etc., you will find out tricone roller bit is a very common bit used for the abrasive material like sandstone, shale etc. In those cases, tricone roller bit is used for rotary drill machine. The factors influencing drilling is considered as the bit type and their geometry, applied thrust and a rotational speed, flushing media and flushing rate, and rock properties. Among these 3 are controllable. The operator can control the bit type, can be controlled one time. So, this is one time control of the drilling system. So, depending on the rock type, you have to choose the right type of bit. Often the manufacturer help you to do that one, but you have to think of the basically few rock properties for which you are considering this bit, that is the hardness of the rock property, strength of the rock property, abrasivity of the rock property. These are the important rock properties you must consider when you are choosing the bit type. Second is the applied thrust and rotational speed. This is with the control of the operator. Operator has to choose the right thrust and right rotational speed so that the proper penetration rate is achieved. Otherwise, it is creating overloading to the drill bit, drill rod, that may lead to the loss of the drill bit, cracking into the rock drill rod. Those will creating problem, and that wear and tear to the machine is must be avoided. And flushing media is very important. First aspect is that you have to take out the rock cuttings, otherwise it will not allow the penetration of the rod, or you will create the jamming of the rod. This will jam the rod inside the hole. To avoid that one, flushing media must work properly. So, this proper flushing media is very important, and proper flushing rate, so that the density of the medium can be controlled very easily. The second important part important activity carried out by the flushing media is the cooling. Generally, to cool down the drill bit, a good quantity of flushing media should be provided, so that the temperature of the drill bit should be kept low at a low point, so that the drill bits and the tungsten carbide tips, these two are having different thermal expansion coefficient, and there should not be, the temperature should not reach such a point, so that the tungsten carbide tips will be lost from the bit. So, that should be avoided, and for that the temperature control is very important. So, that control must be cared properly while one is selecting the flushing media and the flushing rate. The rock, that is the uncontrollable parameter, is defined with the term called drillability. How a rock is easy to drill is basically given by this term drillability. That is, if the rock is, this is how much strong, how much abrasive, what is the hardness, depending on that it is predicted if a certain machine is deployed in the rock, what is the penetration rate will be achieved. What is penetration rate? Penetration rate. So, penetration rate is basically the speed of the drill bit, at which it advances in the hole. So, that means, if you are carrying out drilling and at time t, your drilling bit is at this position, and at time t plus delta t, the drill bit is at this position, and this length, you consider this length is L, then the penetration rate is called L by delta t. So, this is expressed in meter per minute. Sometimes, often in reverse way, you can also express it, that is the minute required for penetrating a 1 meter length. In that case, it is the inverse of this, and then the unit will become minute per meter. So, often sometimes penetration rate is defined in this way also. So, both are penetration rate, you must be very careful about the unit by which it is being expressed. So, that is very important aspects. So, basically penetration rate is governed, we have discussed, by the machine parameters, rock parameters, and obviously application parameters. So, that we have discussed earlier, that what flushing media we are using, how much thrust we are providing, what is the rock, all these are some of the controllable, some what bit you are using. So, depending on that, your penetration rate is being governed by those parameters. Okay. And basically drillability of the rock means it is basically searching of the penetration, possible penetration rate depending on the rock and the machine. So, you can understand the penetration rate is governed by the rock properties, it is governed by the drill machine power, governed by the diameter of the drilling, governed by the inclination of the drilling, types of drilling, flushing media used, and depth of drilling. So, if you are considering the rock properties, the main key rock properties which we consider as the influencing parameters of the penetration rate is strength, abrasivity, grain size and shape, and hardness. So, if the strength of the rock is very high, obviously it takes more time to be fragmented, more time to be cracked. So, that is why the if the rock strength is high, the penetration rate you will obtain is less. So, it is inversely proportional. Similarly, abrasivity is basically the measure of the loss of drill bit, that is on how much the drill peak will be eroded because of the abrasivity of the rock, that is basically governing. At the moment if the peak is become eroded, that means the tips of the drill bit is being eroded, its sharpness will go and it is become blunt. So, the blunt tip means the penetration rate will be suffered. So, if the abrasivity is high, then your tip loss is more, in that case you will receive you will get the penetration rate less. Similarly, grain size is also dictating the abrasivity, the strength of the grain, angularity of the grain, these are basically the governing the high abrasivity. Similarly, high hard means it is also high abrasive. So, these are basically controlling the abrasivity of the rock. So, if in a nutshell, if the rock is strong, abrasive, etc., the penetration rate will be suffered, you will get the less penetration rate. Similarly, if you are looking into the drill machine, the thrust, feed control, automation, intelligent system, these are basically governing the penetration rate. If the machine is automated, the drill bit is automatically inserted or released, in those cases the time will not consume a lot. Feed control, if the proper thrust, proper feed is given, in those cases you will get the better penetration rate. If the low thrust is given, then the penetration rate will suffer. And intelligent system means you are controlling the feed, thrust, all these parameters depending on the resistance received by the rock. In those cases, that is intelligent system developed for the different modern machines, the thrust and feed, etc., are controlled using those cases. So, those machines are better for getting the better penetration rate. Similarly, if the drilling is carried out rotary, then the penetration rate observed is little bit low. In case of percussive, the penetration rate is observed is little bit high, but if you are considering the very strong rock cases, often it may differ. So, this is basically depending on the type of rock and the interaction between the machine with that. So, depending on that, the rotary or percussive is also governing a lot of roles. Then the flushing media, its efficiency, how much cooling is required, sludge material is being generated, if that has to be removed, then the proper quantity of flushing is being provided or not, flush pump is basically giving the proper pressure or not, all these are basically governing a lot to achieve the penetration rate. Penetration rate often low for deep holes, it is high for the initial part. So, depth of the hole is also governing a lot. Diameter of the drilling on which the penetration rate is inversely proportional, because it is easily understood, if the diameter is more, then the penetration will be less. If the diameter is small, the penetration will be very easy, because the rock resistance is less. So, that is why penetration rate here it will get less, here it will go get it more. And this inclination of drilling low for incline hole, because poor control, and if you are carrying out drilling vertically downward, the drilling is being assisted by the gravity. So, that is the better option. But if you are carrying out drilling in the upward direction, in that case the drilling is carried out against gravity, but it is having a benefit that the sludged whatever drill cuttings are there, that is automatically released from the hole because of the gravity. So, somehow it is also beneficial, but in overall the drilling against gravity is troublesome and difficult to control also, and in general that is why it is avoided in most of the cases, and it is not available for the surface mining cases. Now, let us understand about the different terminology related to surface mine drilling. You know, for drilling carried out for the blasting, in blasting while we are carrying out drilling, we are having options of drilling, we are having options of carrying out drilling the holes in which the second row holes are drilled directly behind the first row holes. You can see the holes are of the next row is drilled directly behind the front row holes, and in that case this type of drilling is called rectangular drilling pattern. In rectangular drilling pattern, you can see if you join 4 holes, then a rectangle is being formed. So, often you will find out in some textbook square pattern is also discussed, but square is a special type of rectangle. So, that is why I omit square pattern. I consider square pattern is also a rectangular pattern. So, this is a rectangular pattern in which you carry out drilling the second row hole just behind the front row hole. And you know the blasting terminology. If this is the free face, this is called burden, this is called spacing, and for the second row also the distance from the first row to second row is considered as the burden. Now, in second type of drilling system, you can have the next row hole, you can have the next row hole, you can have this next row hole. Instead of just behind this one, you are just placing this hole between the 2 holes of the front row hole. So, the second row hole is placed in the middle of the first 2 row holes. So, that is why here the direct rectangle cannot be found. So, in this case your drilling system is called a staggered drilling system, in which the next row holes are placed between the 2 holes of the previous row holes. So, the next row hole is placed between the 2 row of the previous 2 holes of the previous row. So, this is called staggered system, and in the staggered system also your concept of burden and spacing is same. So, this is the 2 types of drilling system in general available for the surface blasting carried out by the drilling. Now, if you look into the different unit operations possible with the surface drilling, you can see the first job is the positioning of the machine or propelling of the machine from the right to the right place. So, this is the position of the machine. We are now propelling the machine or allowing the machine to move to the right position. So, this is the right position. The machine has arrived at this right position. Now, the machine is placed at this position and the boom is now lifted and trying it to place in the right spot. Now, it is the drilling is now started in the right spot. So, these photos are taken from the Google photo. So, this is the right spot in which the machine is placed and the drilling is started. Now, when the drilling is started, what will happen in the next phase? Suppose one drill length, that means the rod, this is the rod which is placed at this position. So, this rod is completely inserted, this rod is completely inserted in the hole. So, this is the rod, first rod is completely inserted into the hole. This is the drill bit placed in the mouth of the first rod. Now, for going further drilling, we need to add the second rod at this position. So, this is the second rod, either it is automatically taken or manually it has to be placed at this position, and the shank adapter has to be again allowed to rotate and get fixed with this, then the further drilling has to be carried out. So, you need to insert the second rod at this position. This is called coupling, which is basically joining the rod 1 and rod 2. So, you are inserting the second rod and again resume the drilling. In here you have started drilling, here you have completed the first rod drilling and attach the second rod here. Then you have started drilling with the first rod and second rod together. now you have increased the hole depth up to this. Now, this is the completion of the hole depth say, or if you need to go for further addition of the rod, you can go for repeating this step again. And in this case, let us consider we have stopped at this position, then this is your final drilling length. This is your final drilling length. Now, you have completed the final drilling length. Now, the requirement is that you have to lift this rod up. So, what you need to do? You have to lift this rod in upward direction. So, you are doing that. Now, when you have come out up to this, then you have to untie this second rod. You have to untie the second rod, you have to place that rod in a sideway, then your shank adapter will come and that will connect with this one and it will be lifted. But what will happen if you take out this one without holding this first rod will drop into the hole, then you cannot lift it very easily again. Okay. So, to avoid that one, you have to use a pipe jack and hold the first rod, then you have to untie this one, then you allow your shank adapter to come here and join with this first rod which is now hold in a hold with the pipe jack, then you are taking it out, lift it out finally. So, this is again you are lifting the rod finally, then you are withdrawing from this position and again you are moving to the next hole. So, this is the basically cycle of the different unit operations in general you carry out in a mining purpose. This part is very important. I would like to draw your attention, this holding of this one nowadays with the modern equipment, automatic systems are available, machine is automatically having a pipe jack or you can say rod holder that will hold this one, otherwise it has to be carried out manually, and in that case any slipping of this one, suppose if it is lost at this position, it is very difficult to lift it out, because again say this rod has to be sent, whether it will be aligned properly or it will tie with this properly or not, that is very difficult condition and that must be avoided. That must be avoided in any such situation. So, the whole process I have expressed in this slide. First you need to set the machine, then you need to start drilling, penetrate the rock as per the penetration rate, then add the second rod for further drilling. If you need to go for adding different rods in case of very deep hole, so you have to resume drill and penetration carried out this one. This 2 to 4 will be repeat for the more number of holes. Then you have to complete the reach up to the final depth of drill, then you have to withdraw the drill, then one by one you have to untie the drill rod and again take up the next part. In that case very precisely you need to tie or hold the remaining rock portion which is there, and from this 6 to 7 point you have to complete it unless and until you are moving out of the hole. So, this is the cycle of the hole operations. This is one video from YouTube I have taken here, just look into this. This is basically the automatic rod changing. You can see this rod is being changed automatically. This is untie, this is the breast portion, it is this is shank adapter is coming. This is now again tying with the rod which is remaining in the lower part, the first rod. So, it is now tying with that, you can see the rod is being tied with the shank adapter. Now, it is being lifted off, see the second rod is now being lifted off. So, before that it was the first rod was held with this pipe jack. Now, the drilling with this hole is complete. Now, the machine is moved to the next hole. See, it is now positioned down. Now, the first rod is completing the doing the drilling, started drilling, machine is positioned. first row is started drilling at this position. So, now the penetration, as per the penetration rate, the drill bit is penetrating the rock and going inside the hole. So, now you can see the first rod is almost in completion stage. So, the first rock is now, first drill rod is now complete. And this is the basically the first drill rod drilling is complete, the hole is now clear, trying to be flushed out if anything is there or not. Now, they are untying the shank adapter from the drill rod. See, the shank adapter now is being untied and it is taken up. Now, automatically the second rod will be inserted. Now, the shank adapter is this, automatically the second rod is placed. First the shank adapter is being tied with the second rod, then the shank adapter will rotate this second rod. Now, it is positioned. Now, the second rod is further lowered and rotated little bit, so that it will automatically tie with the first rod. Now, see, it is already tied with the first rod, the rod holder has now released. Now, the second rod drilling is started at this position. So, this is very interesting one. The complete cycle is shown at this position in this video. That is why I have taken this video from YouTube to show you properly. This is a Atlas Copco video, I think taken from the YouTube. So, let us stop at this position. Thank you.